The technical skills a student chooses to prioritize right now will dictate their professional reality by the year 2026. Many computer science students are currently navigating a high-pressure environment, watching headlines about artificial intelligence and wondering if their current path remains viable. Automation is transitioning from simple task execution to a total rewrite of entry-level roles, shifting the requirements for what it means to be a software developer. Success in this environment requires acknowledging that the traditional, predictable rules of career building have been replaced by a more aggressive set of requirements. Conventional education often prioritizes the collection of facts and syntax, but the modern tech sector relies almost entirely on the active application of logic to solve specific problems. This creates a disconnect where students with high academic marks find themselves unable to clear the initial interview rounds at major technology firms. This diagram illustrates the translation gap, a specific failure to convert classroom knowledge into the type of impact an employer actually values. Simply knowing a programming language is no longer a competitive advantage if the candidate cannot demonstrate how that language creates a measurable business result. Crossing this gap begins with the modern raw materials of the industry, the logic of Python, the structure of web development, and the insights of data science. These technical disciplines provide a structured architecture for human reasoning. Learning to code trains the brain to disassemble a large, chaotic problem into a sequence of small, manageable tasks. While these technical abilities are required, they only represent the first half of a candidate's professional profile. Technical skill remains invisible to a recruiter unless the candidate uses a specific mechanism to describe that work in a way the recruiter can quantify. Global companies like Google and Microsoft use a specific evaluation framework called the STAR method to measure this impact. In this framework, situation and task define the environment and the specific technical challenge. The action phase details the exact logical steps taken to address the problem. Finally, the result concludes the story by providing a clear metric, like a percentage increase in speed, that proves the value. Employers use this structure to separate candidates who only have theoretical knowledge from those with actual experience solving problems. The STAR method acts as a scientific proof of how a candidate thinks, communicates, and leads during a project. When a student integrates technical proficiency with the STAR framework, their entire approach to problem solving becomes more methodical. This dual skill set directly increases the probability of advancing through technical screenings and securing offers at competitive firms. Mastering this specific combination of skills allows a candidate to compete for roles in global tech hubs, regardless of their starting point or location. Professional mobility is driven by possessing the specific toolkit that the modern industry is built upon. A student's professional future is determined by their decision to adopt the skills and frameworks that employers are currently hiring for. Barabanki.org, reached at 809-978-0001, provides the specific training needed to acquire both these technical skills and the interview frameworks required for the 2026 market. Developing these competencies today provides a direct path to a different professional outcome.